So, all right, I think we can start. Hello, everyone. Thanks for joining this webinar and welcome. I'm Dmitry Ivanov, Professor for Supply Chain and Operations Management at Berlin School of Economics and Law. Today, we are going to talk about several interesting developments we can expect in the future of supply chain simulation. I've been working in the area for a while, and in the last years, a number of interesting developments have been observed, both in the theory and in the practical industrial project I was fortunate enough to participate in. In addition, there are some interesting ongoing European research projects in this area where my lab is participating. And one day I was thinking, all right, so let us summarize all these developments and present them in a structured way so that the global community can benefit, and so that we all can discuss about these trends which we see in simulation in general, in development of digital twins, integration with artificial intelligence, resilience and control towers. Of course, with a specific focus on the supply chain, which is the main focus of my research, teaching, and industrial activities. All right, so let us start. Let us start, and we can look at the following agenda and the following outline, which I prepared for the next half an hour, and hope we will also have time for some questions, to take some of your questions, but let us see. Also, I'm very happy to see that so many participants came to the webinar, but maybe it will not allow to answer each particular question. So, and I apologize for that in advance. Anyway, I would like to start with digital supply chain as one of the main drivers for rebooting supply chain simulation. I mean, simulation has been here for a while, right? It's not something new and not something what came just in the last years. But there have been several developments which can be considered as a rebooting of supply chain simulation. Second, we will look at the digital supply chain twins. I would like to present my view on it, right? Because a lot of people are asking a very simple question: what is a digital supply chain twin? If I have data about my supply chain, do I have digital twin of my supply chain? If I have a simulation model, do I have a digital twin? Right? So to clarify such questions, we will look at the digital supply chain and twins in general, and then I would like to focus an application example of using a digital twin for resilience management using anyLogistix supply chain software. And finally, my focus will be directed toward intelligent digital twins and human artificial intelligence interface. All right, hope it sounds interesting. And let's start. Well, to start with, simulation as a methodology, it's about imitating the behavior of one system with another, right? And by making changes to the simulated supply chain, we expect to gain understanding of the dynamics of the physical supply chain. In contrast to mathematical optimization, where we rather derive mathematical analytical solution to a problem, in simulation, we experiment with the model and different systems by changing the parameters of the system and study the differences in the outcome of our experiments. Three major approaches to simulation are system dynamics, agent-based simulation, and discrete event simulation. So I assume that the audience which joined this webinar is familiar with these three methods, so I will not go into details. All three methods are very well suitable for supply chain and operations management. Discrete event simulation covers more process level, manufacturing process, warehouse processes, inventory control. Then when we take a more strategic view of the supply chain, then we can look at the system dynamics methods. And when it's about analyzing competition, individual behaviors, individual strategies of companies in the network, then we use agent-based simulation. One can also very nicely combine these methods when developing supply chain simulation models. Supply chain simulation model, right? Again, it's not something new what we developed in the last years, right? So supply chains have been simulated for a long period of time, and they have been simulated successfully. However, there have been some developments in the last years, and these developments raised a number of questions about validity of the state of the art in supply chain simulation. The first question is about real-time data, right? So of course, simulating supply chain with some offline data is fine, but once we get the unique opportunity to work with real-time data, how can we meaningfully utilize this opportunity and enhance our supply chain simulation? The second question is about data accuracy. You know, right? So the quality of data you put into simulation immediately translates into the quality of output, into the quality of results. Right? And again, with the new data analytics technology, we get unique opportunities to increase data accuracy. The third question is about system visibility. Right? So if we talk about complex systems like multi-echelon supply chains, of course, we want to cover as much as possible. But do we really have visibility into the network? Do the companies really know the suppliers of suppliers? You know, if you look quite far away upstream the supply chain. And with the new technologies for supply chain visibility, we get this opportunity to map supply chains and to simulate systems which are very close to reality. Then we have data analytics, right? With completely new possibilities and potential for data processing, data collection, data integration, data processing, and all that, of course, will influence supply chain simulation in future. And finally, the question about decision-making support. What is the final objective of using supply chain simulation? Is it just to get an answer to a particular question, what happens if, or is it about creating a real decision-making management support system, which will be used on a continuous basis by different departments, different managers in the company? I would like to shed light on these questions in this presentation. So, and we start with the digital supply chain. Right? So supply chains are becoming more and more technological systems. Currently, supply chains can be considered as a cyber-physical systems. Right? And digital supply chain is an important part of this system. It is a cyber network of end-to-end visibility, representing physical supply chain with associated operational data and performance analysis. Technologies which we have can be roughly classified into 6 groups at 2 levels, which you see in this slide. Right? We look at the network level and plant level. At the network level, we have Internet of Things, we have 5G in the infrastructure technology. Then we have a lot of data in trace and tracking systems in blockchains. We also have early warning systems, which can provide, for example, early signals about potential disruptions in the supply chains. We have huge advancements in data processing technology, big data analytics. We also have collaboration technology, collaborative supplier portals, like SupplyOn, for example. of companies' internal portals. They all provide a lot of data which can be used for negotiations with suppliers, which can be used for joint collaborative product development and production planning. At the plant level, it's more about real-time process monitoring, sensors, additive manufacturing, mobile robots, RFID, machine-to-machine communications. So this is the level where individual entities in the supply chains are creating data, and then this data can be processed at the network level. When working with companies, my impression is that there are different levels of digital twins in supply chain and operations management. Most of companies already have digital twins of their products, right? Many companies have digital twins of processes, like manufacturing process digital twin or warehouse process digital twin. Some companies also have digital twin of organizations. The real challenge comes at the level of supply chain digital twin. Many companies are interested in and have spent considerable efforts on building supply chain digital twins. And some companies are even interested in network of networks digital twins. So let us look at the digital twins and what components we can consider in digital twins. Right? Obviously, the first function of any digital twin, it's a virtual representation of a physical object. Right? In our case, in the case of supply chain, it can be companies, material flows, which of a physical supply chain, which we represent in a virtual space, in a digital space. But not only this, right? So a digital twin is comprised first of a digital visualization of a physical network and its elements. Second, a digital twin contains technologies which are providing data about the physical object. These technologies can be, again, sensors, blockchains, different clouds, collaborative supplier portals, everything which describes real elements in the network with data. But not only this, it's not enough to represent an object digitally. It's not enough to collect data about this object. The real power of a digital twin comes with analytics, descriptive, predictive, prescriptive analytics for decision-making. So the active usage of collected data with the help of optimization, with the help of simulation, everything what helps managers to improve their decision making. Right. All right. So one very typical question, which is asked both by researchers and by professionals, it's actually a very simple question. What is the difference between a simulation model and a digital twin? So I think there are four major differences. The first one is real-time technology. Right? So a simulation model should not necessarily rely on real-time data. Right? It can use some historical data. It can be run offline. Digital twin should represent a physical object with real data, which implies data collection, data processing, data visualization, and data generation. The second distinctive feature of a digital twin is that it's a combination of different models. It is not just a standalone single model. It is a combination of optimization, simulation, and visualization. Third, digital twin includes not only internal data processing for modeling, but also pre- and post-processing of data in integration with external systems. Traditional simulation model should not necessarily be connected with data sources, should not necessarily make some post-processing of data into, say, specific performance analysis systems. But digital twin, it's a part of a bigger decision-making support system. And finally, last but not least, and maybe even the most important part of a digital twin, it's knowledge. Digital twin, it's knowledge-driven, knowledge transferring, and knowledge creating system using human-machine interface. So digital twin, it's not only a representation of a human knowledge in a model or in a decision support system. Much more important, digital twin, it's able to create own knowledge through artificial intelligence, through human artificial intelligence collaboration, and so help us to understand system, to understand supply chain better. But this is something I would like to focus a couple of minutes later in our webinar when talking about intelligent digital twins. All right, so supply chain analytics plays a crucial role in digital twins, right? And there are four major types of analytics: descriptive analytics for performance visualization, predictive analytics for analysis, like simulation methods, prescriptive analytics, optimization methods for planning, and control, monitoring analytics, which allow real-time control. What are typical examples? Just imagine, put yourself into position of a supply chain manager. Right? So you can be concerned with the question, how was our on-time delivery performance last year? And here, descriptive analytics can help you. Another question you might have is, how resilient is my supply chain and its performance to a supply disruption? Here we can use predictive analytics. We can run a simulation, we can make a stress test of a supply chain and analyze resilience. And another question can be, what can we do to improve our on-time delivery performance next year? And this is optimization, right? Here we suggest the course of action through prescriptive analytics. And finally, a question can be like, what are our inventory and lead times right now? So real-time analysis. And this is what can be done with the help of real-time monitoring and control analytics. One example of a technology which can be used for building digital supply chain twins is anyLogistix. anyLogistix helps us to represent a real supply chain in a digital model, where elements of a physical supply chain, like firms and flows in the network, are represented digitally. So this digital supply chain contains data and analytics to use this data for decision-making. But essentially, in anyLogistix, you can create in a convenient, easy way, digital model of your physical supply chain, describing all your customers, your suppliers, associated sourcing strategies, your production facilities with capacities, production inventory control, considering sustainability issues. You can describe your distribution centers, again, with all the associated parameters. You can describe products your supply chain operates with bill of materials, and you can, of course, define demand of your customers, which can be both deterministic and stochastic, with different ordering, batching rules, and so on. And then all this data can be used for network optimization, for simulation, and performance analysis. So the whole set of descriptive, predictive, and prescriptive analytics All right, let me just remove these drawings so that we can move to the next slide. Yeah, I already see questions and comments, so I will be happy to take them. I think I'll take them after my presentation in a structured way. Maybe it will be similar questions which I can, combine to one answer. All right, so then let us move ahead. So then I promised you to show an example of how digital twin can be used for supply chain stress testing. So just imagine a situation where you have your supply chain model, and here in the middle you have your supply chain model. You have your customers, which are these blue icons. You have your distribution centers, which are these red icons. You have your manufacturing plants, and all that is located in different parts of the world. Right? So then you want to make a sort of stress testing. Stress testing meaning analysis of what happens in the supply chain if you have some disruptions. Like, for example, if there is a lockdown, like during a pandemic in one region, or if there is a long-term strike in one of the region, or if there is a fire at major supply, and so on. So different types of disruption. Then this stress testing, it's possible in two directions. It can be done in a proactive way, where you use some historical data about previous disruptions, right? And then you see, okay, if the same disruptions would happen again, how your supply chain would react. So this is one direction. The second direction is real-time disruption data, right? If a real disruption happens, then the following procedure is used. First, these disruptions are identified. Here, a lot of systems exist. I will not name any particular system, but a lot of systems exist which are based on screening different news, different social network spaces, and which are able to identify disruptions very quickly. They alert you about this disruption. Then next, mapping of risk data and supply chain locations happen. Again, it can be done automatically. It can be done manually. So most of the companies which I have seen do it manually. So automation of this process is still under development. So what happens, companies receive data from this, say, early warning systems, and then manually they allocate them and see, okay, so here's this disruption, there's another disruption I would like to see. Okay, here I don't have any location, so I should not be concerned. But in this area, I have a distribution center, I have many customers, so this disruption is relevant. And once such relevant disruptions are identified, we go to the next step, to simulation of disruption and recovery impact. Right? We analyze how this disruption would influence performance, and we test different response strategies, different recovery policies. What should we change? How we should react to this disruption? So this is a traditional scenario for supply chain stress testing using digital twin. All right. The next topic I would like to focus is intelligent digital. So, as you know, so far we talked about digital twin as a visualization of a real object and using of data for supply chain analytics. And I would say it is digital twin of the first level. Digital twin which visualizes physical supply chain in a digital form, collects and processes data, and uses them for modeling. But it's not the end of the story, it's just the beginning. Even if for many companies, a digital twin at this first level would be a great success. But we think beyond, right? So the second level of a digital twin, it's cognitive digital. Here we add artificial intelligence. We add artificial intelligence to the digital twin. But artificial intelligence of quite straightforward direction. Artificial intelligence that mimics human decision-making rules and suggests some actions. In other words, here we just put some human knowledge which managers have, into the digital twin. And once the same situation happens, a digital twin is able to identify this situation and suggest, for example, some response plan to a problem. But again, it should be an exact match of the situation what a human has already experienced and described good response to such a situation and the real situation. So in other words, here we talk about standard situations. But what happens if we encounter unique new situation? And in this case, we talk about third level of digital twins, which we name intelligent digital. Here, it's not only about mimicking digital decision-making rules which were designed by human, but intelligent digital twin is capable to produce its own knowledge, to create new knowledge, to create new decision-making algorithms and help to react to unique situation which we encounter for the first time. Right? And the idea is that digital twin does not only represent our knowledge, but helps us to understand the system better. And in some situations, such a digital twin can even take over some portion of decision making. Here we come to human decision making, human artificial collaboration, human artificial decision making collaboration. A particular problem exists, and then, for example, AI part of digital twin can tell us, okay, so I know the situation, I know a very good solution to it, I can solve it. Or AI can tell us, no, sorry, so I do not have a good suggestion, good solution. So dear manager, please take it over. I'm happy to assist, but I cannot solve it immediately and to full extent. So this is what we understand as a future trend in simulation, when AI will be added to simulation, and the AI can be added at two levels. Cognitive digital twin level, just replicating human knowledge, and intelligent digital twin level, creating new knowledge. When looking at the future of the simulation from this perspective, simulation can become a major methodology, major technology for building control towers. Right? And control towers of future will be increasingly built using human-machine collaboration. There are 6 major elements of this collaboration, which you can see on this slide: data, human, knowledge, technology, AI, and models. Again, everything begins with data. Data collection, data processing using different types of analytics, and knowledge creation. And here it's a lot about human AI collaboration. Right? On the one hand, humans, based on their experience, help to describe decision-making rules, algorithms, experience, thinking, deduction, creativity, everything what is a human's brain into the digital twin. And on the other hand, we have AI with training and learning environment, with decision-making rules and self-learning and knowledge creation capabilities. Right? So this is something what is so important for design of control towers in practice. Well, another important development which we will see in future, and we already see now, it's industrial metaverse, metaverse supply chain and operations management. On the one hand, we have our physical world with real products, with real suppliers, customers, markets. and real technologies like robots, 3D printers, sensors, smart devices. On the other hand, we have a digital supply chain where we have blockchain, where we have big data analytics, where we have AI, Internet of Things, augmented virtual reality, and so on. And now we can see an increasing trend toward metaverse. Right? So you already see companies which start offering digital products, like, for example, an expensive luxury car. Not everyone can buy expensive luxury car in real life, right? So this product, it's not accessible in physical world, but using, for example, augmented virtual reality, the special glasses, one can buy this expensive car in the metaverse and get some sort of experience driving, expensive car, or going to vacation in metaverse, right? So you don't necessarily need to physically fly in another part of the world and relax on the beach. Just take your glasses and you will have also a kind of experience, right? So it will be so, and this creates a sort of new markets, new customers, new digital collaboration spaces, digital stores, digital twins of factories and warehouses, digital money, and digital supply chain twin in the end, right? So, and this is very, very interesting and important part of future applications related to supply chain simulation when companies have actually two supply chains, a physical supply chain and with physical markets, and also metaverse supply chain where digital products are created and sold to customers. All right, and this is actually one of the last slides which I prepared today. Simulation is a driver of future decision-making systems. I would like to stress that a very clear trend in the future of supply chain simulation, it's a transition from standalone simulation models to simulation as a part of a decision-making support system. Right? So the current state, when I observe practices, experiences of the companies, the current state is data from ERP, TMS, warehouse management systems, MES, 5G, whatever, sensors, RFID. They are already integrated within large cyberspaces in organizations, right? It can be clouds, it can be some collaborative platforms if we talk about networks, talk about Internet of Things and blockchain. So this transition from simple data collection to data integration, it's already a reality, not in all companies, but advanced large-scale technological corporations, they mastered this step. So the transition from data-driven technology to data-driven organization is something what we can already experience now. But what is missing is this transition from data-driven organization to digital management system and decision-making support. So in other words, when you talk to practitioners, when you talk to managers, many of them will tell you, we have good visibility in the network. We have good visibility about our own supply chain. We have good visibility about our external supply chain. But is it a real digital twin or not? Right. So, and there is no standardized answer to this question, because the question of what a digital twin is, it's something what is under discussion, right? Obviously, if you just have data about your supply chain, it is not a digital twin, right? We can talk about digital twin when this data is integrated. But not only this, the data should not only be integrated, but they should be used. They should be used. There should be a possibility for applying simulation optimization, for using AI and generative AI, performance management, process mining. In other words, when all this data, all this integrated data are actively used, where, for example, using some LLM, large language models, or using generative AI, we can really deduce information or even decision-making support suggestion from this data, where we can run simulations and optimization over this data, where the data can where we can make real process mining and use this data, for example, for negotiations with suppliers, right? For negotiations with customers, for understanding risk of supplier concentration, risk of customers concentration. When we can use this data for performance management. Only under these conditions, I think we can tell, all right, guys, so we have built a digital twin. We have technology to collect data. We integrated data into our organization, and we use this data for decision-making support. So these three elements seems to be important and necessary conditions to name something as a digital supply chain twin, where, as you can see, simulation plays an essential role in collaboration with generative AI, collaboration with different clouds, collaborative platforms, and other technologies. All right. So I think that is for this part. And before summarizing this presentation, by the way, I would like to invite you to two workshops which I will run in March. The first workshop will be the academic workshop, which will be run on the March 20 and 21, 2 days, 3 hours each day. And here I will talk about how to use anyLogistix in teaching at universities. You know, if you would like to use anyLogistix in, or if you are already using anyLogistix in your teaching in projects, this is something what I would like to talk about here. And then there is another workshop, professional workshop, which will be on April 25, 26. And this is for industry, for companies, right? If you are interested how to use anyLogistix and analytic digital twins in industrial real environments. All right, so now let us just summarize what we learned today, and then I will be happy to answer your questions. Essentially, I think we have some time for this. So basically, the main idea was to summarize that digital technology offers completely new opportunities for supply chain simulation. Through end-to-end supply chain visibility, we can develop simulation models of completely new quality. And the future areas, such as transition from offline simulation to data-driven digital twins, human AI collaboration, will definitely shape future research and industrial activities in this area. So more or less, the fundamental question is to understand the role and value of real-time data for decision-making. Okay? How a future supply chain manager will take decisions, and how simulation can help in this area. All right, so thanks a lot for listening. Thanks a lot for your attention. Let me just take a look. We have more than 70 comments in the chat and 15 questions, so which it's really a lot. And also given the time line, probably it will be very difficult to me to answer all the questions. But just let me take a look at some of the questions. Yeah, most of the questions, as I'm just screening them quickly, are related to digital twins and integration of different types of analytics within digital twin, and also very good questions about real-time data. So let me just summarize these questions in one short answer. One particular challenge in building digital twins and using simulation in digital twins, it's data correctness, data completeness, and data quality, right? So supply chains are very complex systems. The ambition is that we are good enough to represent all the real data into the digital model. But in reality, it can be difficult, right? So the first question is how fast, how frequent you would like to update your digital model. Would you like to update every minute so that real data are coming again and again? Would you like to update your model every hour, every day? So this is the question, right? This is one question. Another question: do we really have technology for such real-time updates of data in the digital twin? So it should be clarified on that. So we have on the one hand organizational problem, right? So how frequent we would like to update data. And on the other hand, we have technological problems. What sort of technology can help us to update this data? And so this is the first part of the story, right? So how to keep digital twin, say, up to date. And the second part of the story, how to use this data, right? So what's when we use predictive analytics, when we use prescriptive, when we use descriptive. Again, so this is something what I see should be done on the transition from data-driven technology to data-driven organization to a digital management system. Once digital twins become and simulation models become a part of everyday decision-making activities of managers, specific rules, specific application procedures will be developed regarding data updates, regarding using of different types of technologies and analytics, and also specific rules about human artificial intelligence collaboration. I think it's very important, right? We've got a lot of AI in our life, and we've got it in many cases in a very unstructured way, where many things which should actually be organized are not organized. And this is something what will definitely come in the next in the future. So a sort of instructions, right? How humans and AI should collaborate in decision making support. Yes. So I look at the time and I see that the 45 minutes which we planned for this webinar are unfortunately over. If you are interested to get more, to discuss more, I cordially invite you to my webinars in March, both teaching and research and professional industrial webinar in April. They all are announced at anyLogistix website. These are small webinars with about 20 participants, right? With there are a lot of opportunities to discuss individually, to clarify your questions, which is not always possible in such huge webinars like this one. But I hope it was useful to you. I will definitely take a look at the chat and ask questions to understand what sort of questions the audience has. And maybe for the next webinar, already prepare some slides which would explicitly answer these questions. Thank you very much for your attention, and good luck. Stay healthy and see you next time at the conferences or in a digital space at different events. Take care, and goodbye.